Hey guys, we are going to be working on representing subtraction with different size parts. So where yesterday we did addition, today we're going to be doing subtraction, and we're going to be using our visual models to help us. Make sure you have your fraction tiles or the ones we created with cardstock to help you. Alright, Mark and his friends are putting on a play. Mark, and this is page 137 in your book. Mark and his friends are putting on a play. Mark is in charge of the costumes. He measures each sleeve in one costume to be 3/4 yard long. Each sleeve should be a 1/2 yard long. By how much should each sleeve be shortened? So it's important right here to realize it said each one he measures was 3/4, but they should be a 1/2. So it's important for you to realize that a 1/2 is smaller than 3/4. Hopefully y'all are kind of getting them in your mind. You're probably thinking that 1/2 is equivalent to 2/4. So hopefully you would know that 3/4 is larger than a 1/2. So it says, how much should it be shortened? We're trying to figure out what goes right here in this empty space. What is the difference here? What is the difference in 3/4 and a 1/2? What is this portion? So when we're thinking of halves and fourths, there could be several things that you think of that they have in common. You may be thinking just like we said, and what you can see here is that 1/2 is equivalent to 2/4. So I'm going to write our problem down here, 3/4 minus a 1/2. And what we just said was we know that 1/2 is equivalent to 2/4. So you could simply write 3/4 minus 2/4. Now that they're both fourths, we know 3/4 minus 2/4 is 1/4. But maybe you were thinking of a different value. You could also have been thinking of 8ths. We know that 2/8 is equivalent to 1/4. So if I have that, right here, 3/4 minus 1/2. If I know that there are 2/8 in 1/4, 2 4 6/8 would be in 3/4. And I know that 1 2 3 4/8 is equivalent to 1/2. And that gives me 2/8. You might say, but over here you said the answer was 1/4. Well, 2/8 and 1/4. We can put them together and see that they are equivalent. Both answers are correct. You could say 1/4 or you could say 2/8. Now if your answer, if they ask for it to be simplest form, they want it to be the biggest chunk it can be. They want as few pieces. That's simplest, right? Only one piece, where this one has 2. Okay, so that's what that means. So he needs to shorten it by 1/4 yard. YD would be yard. Okay, let's move right along to the next page, which will be 138. Anderson and Joanne sold tickets for the play. Anderson sold 3/4 of the roll of tickets, and Joanne sold 1/6 of the roll of tickets. What is the difference between the fractions of the roll of tickets Anderson and Joanne sold? So here again they have a representation for you right here. We can make it ourselves too. But let's think about what they were saying. Anderson sold 3/4 and Joanne sold 1/6. Hopefully y'all are realizing 3/4, that's almost the whole thing. See it right here? 1/6, that's not very much. Joanne didn't do very much. Anderson was working hard. I don't know what Joanne was up to. Okay? And we're trying to figure out, just like we said in the last problem, what is the difference? What does this missing part represent right here? So we can use, and I like to write it out, 3/4 minus 1/6. We can use our strips here. I'll put them right here. Okay. 3/4 and 1/6, just like we see where the book helped us to represent. Let's think of what numbers we could use that 4 and 6 have in common. You can count by fours. 4, 8, 12, 16, 20. Think of it as sixes. 6, 12, 18, 24. I said 12 for both of them. And like I was saying, we're going to practice these so much that you're just going to start knowing these equivalent fractions. So we know that there are 3/12 and 1/4, and there are 2/12 and 1/6. It takes 2/12 to be equivalent to 1/6. So we could use 12s. Now if I know that there are 3/12 in 1/4, then there'd be 3, 6, 9/12 and 3/4. And we just said there's 2/12 in 1/6. So 3/4 is equivalent to 9/12. 1/6 is equivalent to 2/12. 9/12 minus 2/12 is 7/12. This is a pretty, large amount, and that makes sense because Anderson did way more than Joanne. So the difference between those two would be 7/12. So who sold more? Our boy Anderson. He was not playing around. And we use 12s, like we said. Because they are equivalent to fourths and sixths. Remember, we couldn't just use one that we like. It's got to be able to fit into both of those. Remember, our cats and our dogs, got to make them pets. 6 and our fourths, we had to make them equivalent. What is the difference between those? 7/12. And I haven't really said that, but sometimes you'll see a fraction this way, and usually I try to write them this way, but sometimes you'll see a fraction this way. Still, this is a fraction symbol, which is just a division, really. 7 divided by 12. That's what a fraction is, a division problem. All right, let's look at one more page, page 139. 2 boxes have the same number of play programs. On the first night of the play, Diane handed out 2/3 of a box. On the second night, she handed out 5/12 of the other box. On which night did she hand out more, and how much more? Okay, so on one night, she did 2/3. On the other night, she did 5/12. On which night did she do more, and by how much? Okay, so if we're just thinking about these fractions, let's think about them. Let's say we don't even have our strips. 2/3. If you have something split in 3 parts and you have 2 of them, that's a pretty big amount. 5/12. So I know that half of 12 is 6. So 6/12 would be half. So 5/12 is not even half. 2/3 I know is more than half. So automatically I know that on the first night she did more. If you are not sure of that yet, then you need to try and figure it out. And you can use your strips to help you. And we use those equivalent fractions to help us also. But always, you know how all year we've talked about, does our answer make sense? Well, before we start even doing anything, think about the fractions. Think about how they are. So we said 2/3 is a big chunk of the whole. And if I have 5/12, I said I knew that that wasn't even half. Okay, so by doing this, I can see that 5/12 is less than 1/3. I'm kind of proving that now. If you didn't have fraction strips though, that's where we use these equivalent numbers. So let's think about what could we use. When I think about thirds, I think about 12. Look right here, I already see it. 1, 2, 3, 4/12 exactly fit into a third. So they have 12 in common. So if there's 4/12 in 1/3, then there will be 4 8/12 in 2/3. And then I definitely know 8/12 is more than 5/12. They are represented in the same way with 12. And it says how much more? 8/12 minus 5/12 is going to be 3/12. Here's our 3/12 right here. And that's what fits in this missing spot, would be 3/12. You could also represent 3/12 as 1/4. You're probably thinking those numbers as we've seen them so much. So 3/12 is also equivalent to a 4. We can see that right here. 3 divided by 3 is 1. 12 divided by 3 is 4. Okay, on which night did she hand out more? On the first night. Because we know 2/3 is larger than 5/12. How much more? 3/12 more, or 1/4. And our visual model, we use 12ths to see what was left. Okay. All right, so keep practicing that and complete that homework for tonight. Do your best.